So going along with the electrical theme, I mean, another important factor of this is thermal management, right? So we're going to jump into OnScale. This is a fully cloud simulation tool that leverages embedded AI to enable you to optimize your designs in new and improved ways. So let's take a look at this. So we're going to go ahead and just reference our Onshape design by selecting this button to see our Onshape designs, find the GPS PCB board, and then import it in. Now we're going to start to set up the simulation. This could start with defining part materials. We'll apply a couple here and then skip ahead to a little bit later in the design in the setup. Now we're going to set up the boundary conditions in physics. And you can see there's mechanical physics, there's going to be thermal physics. These are the ones that I'm most concerned with in this case. There's also fluid and electrical physics, and you can combine physics as well. This is a very high-end simulation tool. Think like COMSOL or Abacus, something like that. Once the thermal physics are turned on, we can see the boundary conditions that relate to that, things like power consumption. We're going to assume this IC is going to consume 2 watts. Maybe we'll apply a couple more of these, and then also determine a way for the heat to dissipate using convection, right? From here, we're going to go ahead and we're going to go to the simulator. And the simulator is where it gets kind of really interesting for me, and I kind of geek out on this, but there's some automatic repairs that this tool will do. There's automatic meshing that it will do. All I really need to do is grab this slider and determine whether I want it coarse or fine. Once it's created the mesh, I can visualize it, and you can see it's done a really fantastic job of refining those small features while leaving those inconsequential or large components coarse. So nice mesh you see there. So then comes the estimator. And again, this is something that I geek out probably the most on in this particular product. And this enables us to look at the solve time versus cost. So we're looking at, a solve time of about 2.5 minutes for this first example. If I slide it over to the right, I can get it done a little bit faster using a little bit more of that core hour. But because it's kind of negligible in this case, I'm going to jump back to the original solve and just run it as is. It'll solve very quickly, not as quickly as that. I mean, obviously this is sped up a little bit so we can get through a lot of these, but as I start to post-process it, we'll use that dialog in the lower left to get a real-time feedback of where we're pointing and what the temperatures are at those locations. We can change the palette. I think this Inferno probably makes the most sense for these thermal problems. We can post-process this in a number of different ways. We can slice the model. We can adjust the bounds. We can use log scales, etc. But what we're overlooking in this situation is that these GPS devices are not used in climate controlled office buildings, right? They're not sitting at 20 degrees Celsius all year round. They're used in very extreme climates, such as the most extreme of heat climates, Furnace Creek, Death Valley, where it's gotten up to 57 degrees Celsius. So we're going to make that change. We'll hit solve once again, and we're going to get these results back right away. And again, I can look at the results here and gain a confidence that this thing will not overheat with the loads that it's seeing, and also the temperatures that it's experiencing out in the field, where you definitely don't want these things to fail. So at this point, let's change gears a little bit and let's look at another fantastic part about OnScale. And this is this ability to use a wide range of parameters. So in this case, we're looking at the convection coefficient. We want to use a range, considering maybe the worst case and best case scenarios. Here I can say I want to do a geometric sweep between 2.5 and 25 watts per square meter. And then I can say I want us to solve 50 times within this range. You see how easy that was to set up? Now I go back to solving. The solve time, this kind of blows me away, is still reporting back 2 minutes and 35 seconds, but it's going to use 35 core hours in this case. And that's because they're spinning up 50 different simulations in parallel. So we're going to be able to get tons of results back in a very short amount of time. Once it solves, I can scroll through the different results here, but I mean, what you'd expect is a lot of these plots look the same, just the values that you're seeing are changing. But to really post-process it with high power, we're going to use this Jupyter notebooks, and this gives us this ability to create things like 3D charts to really find the most optimal solution for the design that we're looking at. So this is a product we're very excited about.